Where are these 5 processes actually present?
Where are these processes present? These are actually programs which are running on your operating system. So if you go to the Unix machine and type the command ps-ef, you will see these 5 processes there, one process, another process, third process. You will see that. So the command to find out whether that is running or not. In fact, this is a very commonly used command, ps-ef. It will show you all the processes, that means all the programs that are running on the machine. And if you see that there is a process called as lgwr, then I know that my database is running. If the process lgwr is not running, then my database is not running. That means the correct word is my instance is not running. My instance is not up. My database is always going to be there. Any other things? Okay, so we will now, so ps-ef command, one of the good commands to find out whether these processes are running or not. Okay, now we will go to the next thing now. So we know buffer cache, shared pool and redo log buffer. These are the 3 main areas inside the SGA, inside the system global area. Redo is probably the most important thing from the recovery point of view. Shared pool is most important thing from the performance point of view. And obviously buffer cache is very important from the, again, performance point of view, because data, if it is here, then it will be immediately gone to the user. So certain terminologies that we should be aware of now by this time. I'm just going to make sure that we know these terminologies. We should know as a DBA the difference between, so these are the, what is a database? So what is a database and what is an instance? We should know the difference. So when I say I want to access data in the database, I should be starting up the instance. Then only the data will be accessed. How to check whether the instance is running or not? ps-ef command will show you all these 4, 5, 10 processes, and then you know that the instance is running. And then only you can connect to the instance and you can select. So this is what the instance is. Then the next thing is, what is SGA, system global area? It is part of the instance, system global area. So you should know what is system global area. Now how to find out what is the size of the system global area? That has been defined. The size of the system global area, as we kind of discussed yesterday, will be less than the RAM, total RAM of your machine, obviously. Now it is very critical to decide what is going to be the size of your SGA, and that discussion kind of is very important. We'll have the discussion later, but you can just type the command show SGA. This is a command that you can type inside SQL Plus, which will show you the current size of your entire SGA. Current size of your entire SGA. So you know what SGA is. Now the fourth thing that we know, what is a buffer cache? What is a buffer cache? Then the next thing that we should know is, what is a data buffer? What is a data buffer and what is an undo buffer? Similar to data buffer and undo buffer, there is data block and undo block. Blocks are here, buffers are here. It's one and the same thing though. Okay, data will be read from the blocks and brought it into the buffer. So these things are there. Then you also need to know a terminology called as a, so this is 4A, 4B maybe, and 4C. What is a dirty buffer? Dirty buffer is a buffer inside the buffer cache which has been modified by the server process or server processes, but has not been yet written to the disk by the DBWR process. That is what a dirty buffer is. So it is the job of the DBWR to write dirty buffers from buffer cache to the data files every 2 seconds, 3 seconds, every 3 seconds, whatever it is. Then the next thing that you should know, what is a shared pool? Shared pool is an area which contains so many other subcomponents, and 2 subcomponents which are important are library cache and dictionary cache. Okay, now you can go and find out the information inside the library cache through a data dictionary view. See, all these are areas you can find out what is inside the buffer cache by going through a certain data dictionary view. There is a view called as $BH. Where should I write here? Okay, I will write it here. $BH. This will give you information about what blocks are there in the buffer cache. This is kind of little complicated there, but yeah, I just wanted to make a point. It will be difficult to kind of go and select from $BH and find out what is there. But yes, to view what is inside this buffer cache, you can select from this table. To view what is inside the library cache, you can go and select from $SQL, and there are certain other views also, $SQL. So this is one of my favorite views that I always go and look into. $SQL will tell you what is inside the library cache. So let us say there are 100 users that are connected to your database. And because of those 100 users, there are 100 dedicated server processes. So that is also another term, a dedicated server process. So I will say 5, 6 is the server process. So we know what a dedicated server process is. It's a process that is started automatically when the client wants to log into the database instance. Then client process. What is the client process? Which is the SQL Plus or Toad. All those programs which are running, those are called as client processes. I was saying something about the dedicated process which I just forgot. The authentication is basically checking if the user is allowed to log into the database or not. The checking is login ID password, that's in the simplest way, is done by the dedicated server process. Point to remember, dedicated server process dies off when you log off by typing the exit command. Client process. Then so we have gone through the buffer cache, we have gone through the shared pool, and then the next terminology that we should know, redo log buffer. And then what is inside that redo log buffer? It is the redo vector. And what is one of the important parts of the redo vector? Redo vector is basically the information that is required to redo the transaction in the future. So important parts of the redo vector are the actual statement, that is one of the important parts of that redo vector, and along with that the SCN number. So you should know what an SCN number is now. B is the SCN number, and C information whether it is committed or not. That can be found out by some other pieces of information. So these things are important which are written inside the redo vector, and they help us later on to do the recovery. So this is a word which is loosely used, recovery. What is recovery? Recovery is a process of redoing or replaying a transaction from the redo vectors of the redo file if we need to reconstruct our data. That is the recovery process. Let me repeat that. Recovery is a process of replaying, is a method of replaying the transactions from the redo vectors of the redo file if we need to reconstruct any data in the data file. So that is what the recovery is. Now what is I have talked about one word here without stressing it. It's called as an instance crash. What is an instance crash? When I say my instance has crashed, it means my SGA and my database my processes, they have suddenly died off. It could be because there is a sudden major problem in your system, or it is because the system suddenly crashed, and because of that instance crashed. So the standard process of starting up a server is like this. You start up a machine, the machine starts up, and then you start up the database instance. That means the SGA is captured and the processes are started. When you want to shut the machine down, you do it in the exact reverse way. You first shut down your database instance, and then after shutting down the database instance by typing the shutdown command, then you shut down the database. If you do not do that properly, if you just shut down the machine by typing the init 0 command, in the Unix machine, how do you shut down the machine? Init and 0. Okay, or shut down or power off. There are so many things. So if you shut down the machine without first shutting down the database, then what happens? Then there is a big possibility that somebody had just committed a transaction which is not written to the disk by the DBWR. DBWR did not get enough time to write to the disk, and before that has done, before the transaction is or before the data is written to the disk by DBWR, before that the machine was shut down, and therefore the possibility is very high that data is not written properly to the disk, but there is no possibility that it will not be written to the redo file. Redo file will definitely be written because user has received a message that data has been committed. If before that also, if this LGWR is in the process of writing things to the redo log file, and just within that time a crash happens, then user will never get to see a message that commit has been successful. When user did not see a message that commit has been successful, the data has not been accepted by our system. But when the user sees that message, the commit is successful, that means it is safe. It is in my redo vector. So what is an instance crash? Instance crash is basically wiping off your SGA and your processes suddenly without properly shutting it down, without properly shutting the database down. So therefore obviously two terms that I have introduced here is the shutdown, or maybe I would say for startup. Startup is a command also, and startup is a way is a mechanism to start up the instance, and similarly shutdown. Similarly shutdown.
It will corrupt.
The data might get corrupted. The data will not be written to the disk, and at that time when a instance suddenly crashes, which means the shutdown is not proper. That is what an instance crash is. When the shutdown is not done properly by typing the shutdown command, I would say the instance has crashed. And when the instance has crashed, next time the database is started up using the startup command, Oracle will realize that yes, I need to replay the transactions from the redo file because they were not written to the disk by the DBWR. That is what an instance crash.
It will recover by redo files.
It will recover with the help of the redo files. Yes, the redo files and something in undo. So we will see this recovery word. We are going to go into much details of the word recovery. What exactly happens in the recovery? There is a lengthy process. We'll see that later. But right now, just remember this architecture says that redo is a file which is kind of an important file. It keeps the archive logs. Now, so this much has been kind of understood. Additional terms that we are, so around 11 terms that we have understood so far. Then there is another term here called as 11, maybe 12 now. Background processes. All these processes are called as background processes. Okay, so I'm going to name them DBWR, database writer. This is called as database writer. The job of the database writer process is to write dirty blocks or dirty buffers from buffer cache to the data files, respective data files. Why respective? Because undo buffers will go to undo, data buffers will go to the respective data files. Okay, then B is, we have seen LGWR, which is the log writer process. Log writer process is the one that is going to write things from redo log file, redo log buffer to the redo log file. Now I mentioned that there are two redo log files. At least two redo log files. Why two redo log files are there? Let us not talk about the multiplexing at this time. LGWR is going to write the redo vector at the first. Consider it is like a notepad. You know, just for our ease of understanding, it's a file that we have opened in Notepad. LGWR is going to write at the very first redo vector, then the second redo, third redo, and likewise, the entire file is now full. 100 redo transactions, let us say, are written inside that redo file by LGWR. Now, why only 100? Why not 200? It is dependent on the size of that redo. When we create a database, when a DBA creates a database, he decides what are going to be the sizes of their data files. Similarly, the DBA is going to decide what are going to be the sizes of the redo files. So let us say the redo file size is 10 megabytes. It's a small file. 10 megabytes is the size of the redo. So the transactions are written one after another along with the SCNs, the redo vectors. In that redo file, they are written sequentially. At the end, the redo file is now totally full. So what happens? The LGWR will stop writing to that redo file and start writing to the next redo file. And then it will again start writing those redo vectors in that next redo file. That is what the redo, the LGWR is going to do. And now when this file is also full, then what? Then LGWR is going to come back and going to start writing to the first redo file. But then what happens to the information in the first redo file? It will be overwritten. We don't want it to be overwritten actually, because it's some valuable information. Because if something goes wrong in the database here in this data file, if this data file goes bad, then the transactions in this redo file will actually be useful to us. So before LGWR starts writing the information to the first redo file, there is another process here which is not mandatory, by the way, ARCH, called as archival process, which is responsible for making a copy of this file to somewhere else. So let us say the name of this file is a.log. The name of this file is b.log. Okay, this is the first file, this is the second file. So these first and second, they are called as log sequence number. So the very first time when the database had just started now created, my first redo log file is totally empty, the second redo log file is totally empty, and now I have executed my first transaction. That first transaction is written in the first file a.log. This is the log sequence number. So I say a.log is the name of my redo file, and the log sequence number for that file is 1. And then the first file becomes full, and then LGWR will start writing to the second file. The second file's log sequence number is 2. LGWR totally fills up that file also. Then what happens? Then LGWR will start writing to the first file, but now this will be called as log sequence number 3.
So it means we have number of log sequence.
Number of log, only 2 files. Files are only 2, but their log sequence number keeps on incrementing. So if you give me an idea that, okay, you have a database in your organization, I will ask you, what is the log sequence number of your database? You can go and find out from one of the data dictionary views. And if you tell me my log sequence number is 3489, then it means that so many times your logs have been switched. Okay, LGWR has stopped writing to this and started writing to this one, that is called as a log switch. So that is another term there called as a log switch. What is a log switch? Log switch means LGWR stops writing to this file because it is full and starts writing to the second file, that is called as a log switch. Again, from there to here, logs are switching. LGWR stops writing to one and starts writing to another. So that is what a log switch is. And when the log switches, the log sequence number increments.
Okay, so you're telling about each redo log file is of 10 MB.
Yes.
And we are up to 3000, then we need a lot of disk space to store them.
Yes. So what exactly happens now here? That is absolutely correct. So first, let us now say this was the first file. This is the second file. This file is full. LGWR starts writing to this file. Before LGWR starts overwriting on the first file, archival process will make a copy of that a.log. The archival process will make a copy of that a.log, and archival process will call that as 1.log. Okay, 1.log. That copy of a.log is called as 1.log. Then LGWR will start writing or overwriting on that 1.log. But by that time, this has now log sequence number is 3.
What if the archiving of file is not complete?
If the archival process is slow and it has not archived that file, that means it has not copied the file a.log to 1.log in a different directory on a different disk, let us say, then LGWR will not overwrite a.log. Will not overwrite a.log.
I mean, it will wait for the acknowledgement of the
It will wait for the archival process to finish the log. And this is where the performance tuning kind of comes in. Suddenly your database was going on fine, and then people are intermittently finding it kind of slow. Why intermittently slow? Because the log switch process is slow. the log will be switched. That means LGWR will stop writing to b.log, it will start writing to a.log, but a.log has not yet been archived. And since it has not been archived, LGWR cannot write to this. And since LGWR cannot write to this, why LGWR will write to this? Probably maybe this is full. Since LGWR cannot write this thing over here, then nobody can put any insert statement or update statement over there. And since nobody can put any insert or update statement over here, everybody finds it very slow. So there is no error there, but people will find it very slow. And then after that archival process takes 3 seconds, and then it has done archiving, and then suddenly LGWR will start. So these kind of performance tuning issues will come. How to find those, how to kind of identify those, we'll see that later. But just understand now that yes, this could happen. This could happen. So first file is now 1.log. Now LGWR has now overwritten this file. It is log sequence number 3. By that time, hopefully 2.log has also been copied over there. Then LGWR is gonna start overwriting this file. The log sequence number of this is now 4, and now by that time archival process will do archiving of 3.log. Likewise. And then as your database is now moving in time, let us say your database was created 6 months ago. So many log switches have happened so far. If you go to this directory, this is a directory or a drive error, and if you see the archive log files there, you will see it from day 1, 2, 3, 4, 5, 6, 7, and all the way those archive log files are going to be there. And are they really required? They are required if you really need to do recovery. And we will talk about that recovery in other words in some other time. But yes, those archive log files should be backed up somewhere to the tape, so that if required we can bring them back. If required we can bring them back. So that is what the archival process is.
So it means we need to assign a lot of memory space for that archive.
Yes. And I will tell you, one of the very first problems as a DBA that you will get in your career is that one fine day everything was going on fine, but now 10 o'clock in the afternoon suddenly nobody can do any work. All 100 users will start complaining that we cannot do. Database is like kind of frozen. I cannot even log in, no logins are accepted. People who are already logged in, they will find it very slow. Nothing will work. And how does that work? Your C drive, let us say this was your C drive, which was having a disk space of 50 gigabytes. All that entire C drive is now full with your archive log files. Since entire C drive is full with your archive log files, that archive log file cannot create an archive log file. And then the ripple effect will start from there, and nobody would be able to do anything. The ripple effect will start like this. Since archival cannot be creating, then LGWR cannot overwrite. Since LGWR cannot overwrite, this will become very full quickly. And when this will become full, nobody can enter any DML operations. Select statements will keep on working. That is an important thing to understand. Select statements will keep on working, but insert, update, delete, those things will not work. And Oracle from that point onward will not allow anybody to log in. So this is
it is like read only.
It is like read only means
that means this file select statement is only print the value.
Select statement is not changing any data. That's why that will work, because it doesn't require any entry in the redo log buffer.
So will it write over the lines which have been archived? Not the whole that file is archived, but few of the lines are archived. So will it overwrite those lines?
No. The whole file has to be archived. Once the whole file is archived, then only LGWR will start overwriting on that file from the top. So what is a log switch? This is also a term, ABC. Then this is a D. What is a log switch? People will ask you, what is a log switch? LGWR stopping writing to the one file and starting writing to the next file. What is a log sequence number? It is a number given to each redo file, and it keeps on incrementing, starting from 1, 2, 3, 4, 5, 6. Just like the SCN number changes from or increments from 1, 2, 3, 4, 5, 6, 7, 8. SCN number is for each transaction. The log sequence number is for each redo file. So there is a difference between the SCN number and the log sequence number. There is a big difference between the SCN number, which is for each transaction there. So what could happen that for log sequence number, let us start from 1. In this log file number 1, log sequence number 1, there are SCN numbers starting from 1 all the way to maybe 1000. Let me repeat this thing. The first file, redo file, is a.log. Log sequence number for that file is 1 because we have just started our database. In that first file, there are transactions, there are redo vectors there. Those will have SCN number starting from 1 to, let us say, 1000. Then once that is full, then starting from 1001 till maybe 2000, maybe whatever, maybe 800, maybe 1800, that will be in log sequence number 2, and then 3, and then 4 and 5. So log sequence number increments slowly, the SCN number is incrementing faster.
We are still in the middle of disk management. No?
We are still in the middle of disk management there. I mean, I didn't get you.
That where we put this 1.log, 2.log, 3.log,
when that becomes full. When that becomes full, the simple effect, ripple effect, is that when this becomes full, this guy will not be able to, archive will not be able to put anything over there.
This is the effect.
This is the effect.
So what's the
what should be done? Okay, the solution I did not discuss. The solution is, okay, I jumped from one point to another. That's what he said. Okay, that is my bad habit. So you need to stop me that. So the solution to that is to delete these files and put them to a tape.
Okay, our
external disk. Put them somewhere to tape. That is the solution there. Or another solution is that give an instruction to the archive log file that do not archive to the C drive, now archive it to the D drive. You can change the destination where the archiving happens. So that is the solution there.
And where is this archive? This directory.
So that is a directory that we are going to create. Okay. It is just a directory that we create. If that directory is full, we give the name of the other directory. Wherever we tell them.
Create this.
Wherever we tell them.
I mean, in the C and the D.
Yes. C drive, D drive, or some directory within C drive, some directory within D drive. That is what we'll be doing.
How to change the location after this?
Command. There is one simple command: alter system. So we will. So now on Monday we are going to. Now I'm not going to go into too much of a theory after this. On Monday we will actually create the database. When we are going to create the database, we will be actually setting up the log archive destination. We'll be setting up the sizes of this thing and all that stuff. That is what we'll do. So I'm going to stop only up till this point. All these are terminologies that we have seen so far. And there is a lot of discussion that again needs to go within this point, especially a control file. We haven't done a lot of discussion about control files yet. But I'm going to stop here, and then we will now continue with the database creation, and then after that again we will come back to certain other smaller points here and there. And again during the recovery, I'm going to talk about the architecture. So I think you will find it maybe sometimes very boring, or maybe sometimes same things are again are getting discussed again and again, but smaller points will be kind of elaborated over there. So just that one small point which I went across, which I should have discussed, again you are correct, during the recovery process, is that SCN numbers are within the log sequence number. So we'll talk about that point again one more time. So if you forget about almost all those things, those terminologies that I had written over here, those new terms, those are the ones that you should kind of memorize. So we'll stop now, and then we'll work on database creation.